Hi everyone, welcome you all to the Brilliant Group of Institution. Today we are here to discuss one of the most important concept from your grade 11, the fourth chapter, chemical bonding. In chemical bonding, we have to know, if you want to answer so many questions, we have to know what is the shape and the geometry of a molecule. Suppose I am asking you, what is the shape of and the shape and geometry of water molecule? What's your answer? Okay, you may think, okay, yeah, H2O is the bend geometry. If you maybe studied that, bend geometry, bend shape, something. So shape and geometry, something a difference, right? Let's see. So in this video, we are going to study three things common together. Okay, that's all in one. First of all, VSEPR theory. What is VSEPR theory? Valence, shell, electron, pair, repulsion theory. VSEPR theory. What is the use of this theory? This theory mainly using to study or to discover what is the shape and geometry of a molecule. What is the shape and geometry of a molecule? Next concept we are going to discuss, that is called hybridization. Hybridization and the shape and geometry of the molecule. That is the main purpose of which one? VSEPR theory. Dear all of you, let's begin to the concept. Directly when we can enter into the VSEPR theory, there will be a small confusion. You may feel a small confusion. So let me clear a basic ideas. First of all, let us discuss what is the meaning of a bond pair and lone pair. Okay, bond pair and lone pair. All right. You consider one of the example, ammonia, right? You can see ammonia. Let me take the ammonia molecule. Which is the central atom in ammonia? How to find out the central atom? Generally, in NH3, one nitrogen and we have 3 hydrogen, right? Which is the smaller number of element nitrogen. Mostly, which is smaller in number, that will be the central atom, most cases. So here, nitrogen, 1 nitrogen, 3 hydrogen. So which is the central atom? Nitrogen. All right, nitrogen. You know what is the atomic number of nitrogen? That is equal to 7. All right. So what is the electronic configuration we can write for nitrogen atom? That is 2, 5. All right, 2, 5. So what is the valence electron on nitrogen, dear all of you? What is the number of electron in the outermost shell or the valence shell of nitrogen? That's equal to 5. Yes or no? All right. Now, nitrogen is there. Valence electron 5. Why I'm not representing only the valence electron? What about the inner electrons? You know, valence electrons only can take part in bonding. So we have to represent only valence electron. All right. So nitrogen 5 valence electron we represented. Which is the surrounding element? Which is the surrounding element, dear all of you? 3 hydrogen atom. All right. I'm just representing hydrogen. You can represent anywhere, no issue. What is the atomic number of hydrogen? 1. And what is the number of valence electron on hydrogen? You know, hydrogen only contain 1 electron, right? In K shell, 1 electron. So there is 1 electron on hydrogen. All right. So if you want to, the hydrogen, how they can attain stability? It need 1 more electron. Okay, let them take from nitrogen. The next hydrogen need 1 electron from nitrogen. The other hydrogen, 1 electron from nitrogen. So you can see these 2 electrons are not take part in bonding. So this is known as what? Lone pair. Lone pair. So what is mean by lone pair? They are the pair of electron which are not involved in bonding. The pair of electron which are not involved in bonding. That is called lone pair. So what is bond pair? Those electron which take part in bonding. Those electron which take part in bonding is called what? Bond pair. So these 2 electrons involved in bonding. So this is one bond pair. This is one another bond pair, another bond pair. So total how many bond pairs and lone pairs are there on the nitrogen atom or in the compound? You can see that on nitrogen atom 1, 2, 3. There are 3 bond pair. Just this is, no, 2 electron means 1 pair, right? 2 electrons mean 1 pair. This is 1 lone pair, all right? 1 lone pair. So in ammonia molecule, there are 3 bond pair, 1 lone pair. If you want to identify the number of bond pair, you can take it as how many bonds are there on the central atom. Some exceptions are there, I will tell you later. Now let us discuss, dear all of you, what is the number of bond pair and lone pair in water? H2O. Which is the central atom? I think oxygen is the lesser number, right? Oxygen is the central atom. Okay, oxygen. What is atomic number of oxygen? That is equal to 8. So what is the configuration? 2, 6. So what is the valence electron on oxygen? 6. Let me represent 1, 2, 3, 4, 5, 6. Okay. Which is the surrounding element here? Hydrogen. How many hydrogens are there, dear all of you? 2 hydrogens are there. Each hydrogen carrying 1 electron in their outermost shell, right? Yes, let them take 1 electron from oxygen atom to complete their valence electron 2. So these are 1 lone pair, second lone pair. So can you tell me how many bond pair and lone pairs are there in this compound? On this central atom oxygen, how many bond pair? 2 bond pair, and we have 2 lone pair. All right, 2 bond pair and 2 lone pair. This is the way how to find out bond pair and lone pair. Then you can ask the questions like, why we are calculating bond pair and lone pair? Dear student, if you want to determine the shape and the geometry of a molecule, first thing we have to know how many bond pair and lone pair on the central atom. This is the simple way. Alright, now let me go to the next concept. How we can find out the hybridization, the maximum questions we can discuss in this video. Okay, this is the beginning part, just wait. Hybridization. What is mean by hybridization? Hybridization mean mixing of atomic orbitals. What are atomic orbitals we have in structure of atom? You may study the orbitals. You have s orbital. You may study spherical shape. P orbital. You may study dumbbell shape. D orbital. We studied double dumbbell shape. And F orbital. F orbital not needed in hybridization. Let me just leave F orbital. SPD, that's the maximum they will ask you for your exam. Even NEET, JEE, IIT, or the entrance examination also, they will ask you only from this area. How many s orbital you have? Only one type of s orbital, right? We will write only one orbital. How many p orbital you have? 3 p orbital, right? We will write like this. What are the p orbital? You know, px, py, pz. All right. How many d orbital you have? 5 d orbitals, right? 5 d orbitals we have. What are they? dxy, dyz, dxz, dx square minus y square, and we have dz square. These are the 5 d orbital. All right. So once again, I'm repeating. You have only one s orbital, 3 p orbital, 5 d orbital. All right. Fine. I'm just writing here. This is the one s orbital. 3 p orbital, right? So 1, 2, 3. 3 p orbital. How many d orbital? 5 are there. So 1, 2, 3, 4, 5. Okay, just keep it there. Let me discuss. Or suppose they are asking you, what is the hybridization in ammonia? Let's find out. You know, ammonia, let me take it, dear all of you. Before that, let me tell you, hybridization. Hybridization is calculated, is a simple method. Hybridization is equal to number of sigma bond plus number of lone pair on the central atom. On the central atom, how many bond pair and lone pairs? Like how many sigma bonds and how many lone pairs are there? You just count it. Take the sum. Okay. Let me take the example ammonia. Okay, we have nitrogen atom. What is the number of valence electron on nitrogen? We discussed, that's 5. It is surrounded by how many hydrogen atom? 1, 2, 3. Each hydrogen need 1 electron. Okay, let them take. So you can see this one, a lone pair. Can you tell me, dear all of you, how many sigma bonds are there? You know, all single bonds are sigma bond. This is sigma, 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 right? How many sigma bonds are there? 3 sigma bonds are there plus how many lone pair? Only 1 lone pair. All right, 1 lone pair. That's equal to 4. Why we calculate a sum here? Total sum is equal to 4, right? For hybridization. What is that sum meaning? I told you hybridization means mixing of orbitals. Atomic orbital S, P, 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 D, 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 D. Their mixing is called what? Hybridization. So your total sum of hybridization is equal to 4, which meaning first 4 orbital you mix it. first orbital. You cannot mix it from here and there, okay? You should start from s orbital onwards. Okay, 4 orbital, first 4 orbital we can mix it. So that is 1 s orbital, then p, p, p. Total first 4 orbital I'm mixing. So how many s orbital you consider? Only 1 s orbital. How many p orbital? 3 p orbital. So what is hybridization? sp3. sp3 is the hybridization. Such a way we can find out hybridization for every compound. Let me go to water. Okay, dear all, water. What about water? In the case of water, we have, I told you oxygen is the central atom. There are 6 valence electron on oxygen atom. It is surrounded by 2 hydrogen atom. They are taking 1 electron each. So can you please count total how many sigma bond and lone pair in the system? I think this is 1 sigma bond. This is 1 sigma bond. So sigma bond is equal to 2. How many lone pair? 1, 1. Total 2. So total is equal to what? 4. Here again 4. If it is 4, again hybridization same. 1 s orbital, 3 p orbital. Hybridization is sp3. Clear all of you? This is the way how to find out hybridization. Please wait. We can discuss maximum 12, 13, 14 compounds how to determine hybridization in the coming topic. Next one. How to find out the geometry and shape of a molecule. So you may think, what is the difference between geometry and shape? Both are same, right? No, there is a small difference. When you calculating geometry of a molecule, you have to consider both bond pair and lone pair on the central atom. Once again, all of you, if you want to calculate the geometry of a molecule, you have to consider both bond pair and lone pair on the central atom. Then what about shape of a molecule? You have to consider only the bond pair. If when you calculating shape of a molecule, you have to consider the only bond pair. Clear all of you? Let us discuss, don't worry. You can see here in this table, I'm just to mention geometry, shape, how to determine. I will tell you in the next topic. You can see, I told you, if you want to calculate the geometry of a molecule, we have to consider bond pair and lone pair together. You take the sum of bond pair and lone pair on the central atom. If it is equal to 2, just all of you, you can take a screenshot or you can pause the video. You can just note and study this table. Okay. This, if the sum of bond pair and lone pair on the central atom, suppose it is equal to 2, we will call the structure or the geometry is called linear. If it is equal to 3, it is called trigonal planar. The total sum of bond pair and lone pair, if it is equal to 4, we will call the geometry tetrahedral. If it is equal to 5, it's called trigonal bipyramidal. If it is equal to 6, octahedral. Octahedral is also known as square bipyramidal, and 7 is known as pentagonal bipyramidal. Each and every structure, everything we can discuss detail. Just wait, all of you. Please take a screenshot now. Okay, I will give you 3 seconds, or you can pause the video. Then you can go through the just reference, or you just note it in a paper. Then when I'm discussing the next topic, you can cross check with this one whether it's correct or not. Okay. So this, if you know the bond pair, you know how to calculate the bond pair and lone pair on the central atom. Now, take the sum of bond pair and lone pair. If it is equal to these digits, the geometry will be this digit. Okay, this will be the geometry. Okay, hope you noted already. Let me go to the concept. One by one we can discuss, dear all of you. Now we can move together. One by one we are going to discuss how to determine the shape, alright, the shape, geometry, hybridization, and which molecule type is this. All together we can discuss with a one by one example. Dear all of you, first I am taking the example BeCl2, alright, beryllium and 2 chlorine is there. Which is the central atom here? Beryllium. That is the lowest in number. Okay, let's start, dear all of you. Beryllium is there. What is the atomic number of beryllium? 4, right? Hydrogen, helium, lithium, beryllium. Beryllium atomic number is equal to 4. So here, beryllium 4 means the configuration what we can write 2, 2. So what is the valence electron? 2. Alright. So beryllium valence electron is equal to what? 2. Now, It is surrounded by which element? Chlorine, right? Chlorine. Okay. What is the atomic number of chlorine? Chlorine atomic number is 17, right? Chlorine atomic number is 17. So what is the configuration? 2, 8, 7. 2, 8, 7. All right. So what is the valence electron on chlorine? 7. Okay. One more thing. Please get the halogens, right? Halogens. What are the halogens? We have fluorine, chlorine, bromine, iodine. What are they? Fluorine, chlorine, bromine, iodine. These are the halogens we have. Halogens, their outermost electrons all are 7. Okay, just keep in mind. Because, those elements which are located in the same group having same number of valence electron. Halogens means 17th group element, fluorine, chlorine, bromine, iodine. All their valence electron same like chlorine. Which one? 7. Alright, so let's go. Here. So we noted beryllium is the central atom, 2 is the valence electron surrounded by 2 chlorine atom. Alright. Chlorine, how many valence electrons are there, dear all of you? 7 valence electron, right? I'm not writing completely. So each chlorine to complete its octet, how many more electrons require? 1 more electron. Correct. Because already 7 is there. 1 more electron needed. It can take from beryllium. Here also taking from beryllium. Okay, bonding, everything is over. Now, okay, let us find out how many bond pair and lone pair on the central atom beryllium. You can see there. How many bond pair and lone pair, dear all of you? There are 2 bond pair. Yes or no? There are 2. Single bonds are generally sigma bond. Number of sigma bond. That is a number of bond pair you can consider. So, 2 bonds are there. Therefore, bond pair is equal to 2. Can you see any lone pair on the beryllium? No, right? All the electrons already involved in bonding. So, 0. So, 2 bond pair, 0 lone pair, it is the system. Got it? In BeCl2, there are 2 bond pair, number of bond pair, number of lone pair. 2 bond pair, 0 lone pair. Now, we can go to the system. First, I am going to calculate the geometry. Okay? The geometry. In order to calculate the geometry of a system, what all things we have to consider? We have to consider both bond pair and a lone pair. Okay, if you want to calculate the geometry, you have to consider both bond pair and lone pair. But if you want to know the shape of the molecule, what we need? Only bond pair. Alright, that's a small difference. So bond pair is equal to 2, lone pair is equal to 0. Take their sum, 2 plus 0, that's equal to 2. Alright. In the previous one, I show you one of the slide. What is that? If the bond pair lone pair sum is equal to 2, if the bond pair lone pair sum is equal to 2, what is the geometry is called? Linear geometry. What is that? Linear geometry. So we got it. What is the geometry of the system, dear all of you? Linear, right? We can write it here. The geometry is what? Linear. Linear. Alright. So I will draw you the picture and the bond angle, everything later. Let me go to the shape of the molecule. Shape. If you want to know the shape of the molecule, we have to consider only the bond pair. Yes or no? Only the bond pair. Fine. How many bond pairs are there, dear all of you? There are only 2 bond pair. If there is only 2 bond pair, structure is like this. Beryllium, chlorine, chlorine. If there are 2 bond pair only, the shape of the molecule again linear. And I will give you one short idea. Just note it. In this case, in this system, lone pair number is equal to 0. Correct or not? Lone pair is equal to 0. In any system, if the lone pair equal to 0, you can say that the geometry and the shape both are same. What is the point, all of you? Just note it. If the number of lone pair is equal to 0 on the central atom, geometry equal to shape. Okay, geometry will be same like shape. So here also, what is the shape? Linear shape. This will be the diagram. We can see here, this will be the geometry. What is the central atom? This is beryllium, and these 2 white things are which one? White balls are chlorine. Beryllium at the center, chlorine here and there. Which is system? 2 bond pair, 0 lone pair. So in any system, Any compound, suppose you can ask the question, so what about other compound? If they're given the same another compound, suppose I'm getting 2 bond pair and 0 lone pair, can we follow the same method? Yes, of course. If 2 bond pair, 0 lone pair on the central atom for every system, this is the geometry, this is the structure. It is fixed one. Alright, so here, can you answer me? Why here geometry and the shape of the molecules are similar? Because the lone pair number is equal to 0. So this is a geometry, central atom, what is this? This is beryllium and it is connected here 1 chlorine, here 1 chlorine. Can you tell me what is the bond angle here? What is meant by bond angle? The angle between 2 bonds. What is the bond angle? This is what? 180 degree. Alright. So linear geometry, what is the bond angle? 180 degree. So are you clear what is geometry and shape? Now we can go to the hybridization. Tell me how to determine the hybridization. Hybridization is calculated by the sum of sigma bond and lone pair on the central atom. Okay, let's go. On the central atom beryllium, how many sigma bonds are there? 1, 2. 2 sigma bond. Any lone pair? No. So 2 bond pair, 0 lone pair is equal to 2. Dear student, hybridization 2. Total sum is equal to 2. So which all orbital we want to mix it? Which is the first orbital we have? S. What are the p orbital? P, P, P. 3 p orbital, right? Then d orbital. You want to mix only 2. First 2 things you mix it. 1 s orbital and 1 p orbital. 1 s orbital, 1 p orbital you mix it. So what is the hybridization? sp hybridization. sp hybridization. sp means generally linear in geometry. So hybridization is also ready. What is that? sp. One more point we are going to discuss. Which type of molecule is this? Which type? Which is very simple. Dear all of you, always consider I'm representing A, B and E. A represent the central atom. A represent the central atom. B represent the surrounding element. Okay, the surrounding element. The surrounding element. Surrounding element. E represent lone pair. Alright. E represent lone pair. A represent the central atom. B represent the surrounding element. E represent lone pair. All of you, dear all of you, in this question, BeCl2. Which is the central atom? Beryllium. So this is A. Only one beryllium, right? Okay, A. Which is the surrounding element? Chlorine and chlorine. How many chlorines are there? 2 chlorine. So, surrounding element we considered as what? B. So, A, B, 2. One central atom and 2 surrounding element B. Alright, A, B, 2. Any lone pair in the system? No. So, A, B, 2 is the system. Alright, A, B, 2 is the system. One central atom is there, 2 surrounding element is there. Just their number. That's a type is called AB2. We'll discuss maximum question, maximum compound formulas. I'm going to the second system. One of the example I'm giving you, sulfur dioxide. Okay, let's go. Let me take the central atom, dear all of you, sulfur. Sulfur, you know, atomic number of sulfur is 16. So what is the electronic configuration? 2, 8, 6. Valence electron 6. Alright. So 1, 2, 3, 4, 5, 6. It is surrounded by which element? 2 oxygen atom. Okay. I'm writing 1 oxygen here, 1 oxygen here. What is the valence electron on oxygen? That's again 6. Oxygen also valence electron 6, dear all. Okay. Now let's see in this point. If you consider the left oxygen atom, the left one, already 6 electron is there in the outermost orbit. In order to complete its octet, how many more electrons are required? 2 more electrons, right? Okay, let them take from sulfur. It's making a double bond. Similarly, this oxygen, if it want to complete the octet, let them take 2 electrons from this side. Again, a double bond. What is this? This is a lone pair. Okay, fine. Now we can go to the concept. Alright. First, what you need? Are you sure? 2 bond pair and 1 lone pair in the system. So you may think, no sir, this is not 2 bond pair. 4 bond pairs are there. Yes or no? That's your confusion, right? There are 4 bond pair because there are 4 bond. No. According to VSEPR theory, just note it all of you. According to VSEPR theory, multiple bonds are considered as a single bond. What's the point? According to VSEPR theory, multiple bond in the sense either double bond or triple bond, they are considered as a single bond. You can see this is a double bond, right? Treat it as a single bond. Another double bond, treat it as a single bond. So here actually two double bonds are there, which mean two single bond. Alright, so here there are, what is the number of bond pair? Is equal to 2. Don't take it for okay. If a double bond comes, take it as a single bond. Alright, according to VSEPR theory. So this is one single bond, this is one single bond. Total there are two bond pair. How many lone pair? Lone pair is equal to 1. Alright, take their sum. 2 plus 1 is equal to 3. Dear student, what is the geometry for 3? When you take the sum of bond pair and lone pair, if you are getting is equal to 3, what is the geometry? You can see the table we discussed in the previous slide. The 3, if it is the sum, you can say that the structure is called trigonal planar. Trigonal planar, because in order to determine the geometry of a molecule, we are considering both bond pair and lone pair. Then what about the shape? If you want to know the shape of the molecule, we are considering only bond pair. Correct or not? Only bond pair we are considering. How many bond pairs are there? Only 2 bonds pair. If there are 2 bond pair and 1 lone pair, right? We already said trigonal planar. Then what is the shape? In the previous slide also we discussed only 2 bond pair, that was linear. But here the structure is bent. Bent shape, or we can call V shape. Bent or V shape. Bent or V shaped molecule. Why bent? Why bent? Dear all, according to VSEPR theory, let me tell you one more important data. According to VSEPR theory, lone pair repulsion. 2 lone pair, you know, this is one lone pair, this is another lone pair. When they come closer, they will repel very high. Lone pair repulsions are very greater than lone pair with one bond pair than bond pair repulsion. So 2 lone pair at any cost, they can't stay very nearby, because there is a large repulsion. So here there is a lone pair and this is a bond pair. This is a bond pair. 2 bonds can come closer, no issue. There is not that much repulsion. But 2 lone pair at any cost should not come closer. Alright, so this is according to VSEPR theory. Now, as I told you, there is no confusion in the geometry of which one? SO2. 3 is the sum, so trigonal planar. What is the shape, or why the shape bend? Let me tell you. Here, sulfur is there, alright, sulfur. Bend means double bond O. This is the situation. A bend geometry or V shape. Where is a lone pair? Right, here is a lone pair. When you drawing the shape of the molecule, of course, bond pair and lone pair should be there, okay. When you are assigning or when you are calculating the shape of the molecule, we are considering only the bond pair. See all of you, how the bonds are located. Or what is the shape of the bond? You just don't bother about the lone pair. I told you, when you're calculating the shape of a molecule, you no need to bother about the lone pair, how they located. Just leave it. How the bond pair located? Just like a bend geometry. Bend or V shape. Then why it is bent? Because dear all of you, can you see this is a lone pair, right? This is a bond pair, right? They will repel. Bond pair and lone pair will repel. So these bonds will come closer. Why it is not happen in the previous case? Here there is no lone pair. No lone pair means this is the relaxed state, right? So linear geometry. When a lone pair comes here, become bend. Bend geometry. Bend shape is the shape of the molecule. Now you may think, okay sir, this is the shape of the molecule SO2. You said it is bend geometry. Okay, fine. Then can you draw the geometry of the molecule with a trigonal planar shape? Of course. Let me draw. Sulfur is there. Okay. This is one lone pair, double bond O. Correct. Double bond O. Here, I told you, when you assigning the geometry of a molecule, you have to consider in the lone pair also, right? Lone pair also. Now you see, lone pair is there, bond pair, bond pair. How they located? It's just like a trigonal planar. Trigonal planar. So when you assigning the geometry of a molecule, we are considering lone pair also. But about when you consider the shape of the molecule, we consider only the bond pair, how they located, not lone pair. Clear? So where every system with a 2 bond pair and 1 lone pair, the geometry is called what? Trigonal planar, and the shape is bend or V shape. Can you assign the hybridization? Yes, let's go. Hybridization is equal to sum of sigma bond and lone pair. How many sigma bonds are there in this compound? Dear all of you, in a double bond, you know 1 sigma, 1 pi. 1 sigma, 1 pi. So how many sigma bond? 2 sigma bond and 1 lone pair. So 2 plus 1, that's equal to 3. Your total sum is equal to 3. So first 3 orbital, all of you mix it. Take s orbital, 2 p orbital. So what is hybridization? sp2, right? sp2 is the hybridization. Can you tell me what is the type of the molecule? You know, central atom. How many central atom you have? Only 1 central atom there, A. That is sulfur, A. How many surrounding element you have? B. Alright, B2. Do you have a lone pair? How many lone pair? 1 lone pair. Therefore, E. A represents central atom. We are just taking the numbers, okay? How many central atom? 1 central atom, A. How many surrounding element? 2 surrounding element, B2. And how many lone pair? 1 lone pair. So the type of the molecule, I can say that this is called AB2E type molecule. AB2E type. Now, what is the bond angle here? The sulfur dioxide bond angle is nearly 119 degree, approximately 120 degree. See, linear geometry, what was the bond angle? 180 degree. Why they reduces? Because the lone pair, bond pair repel, so bonds will come closer. Alright, let's go to the next system. Okay, this is the geometry, okay? This is the 2 bond pair, sulfur, oxygen, oxygen. This is the bend geometry. The bond angle is 119 degree in SO2 molecule. Where is the lone pair? Lone pair will be here. Okay, lone pair. Next concept we can take it, the system which contain 2 bond pair and 2 lone pair. One of the simplest example, or the very most important example, every time we are discussing that, water. Alright, what is the shape and geometry and the hybridization, molecule type, everything we can discuss all together. Water, which is the central atom, dear all of you, oxygen. Oxygen, what is the valence electron? 6 is the valence electron. It is surrounded by how many hydrogen atom? 2 hydrogen atom. Each hydrogen need 1 electron. So totally you can see there how many bond pair, dear all of you, on oxygen? How many bond pair? There are 2 bond pair. How many lone pair? Come on. There are 2 lone pair. Yes or no? 2 bond pair, 2 lone pair. Yeah, 2 bond pair, 2 lone pair. Okay. If there are 2 bond pair and 2 lone pair, take their sum. Bond pair plus lone pair is equal to total 4. If the sum of bond pair and lone pair is equal to 4, can you look into the table? What is the geometry? Sum of bond pair and lone pair, if it is equal to 4, geometry is given. You can observe that tetrahedral geometry. Can you notice that? Tetrahedral geometry. Tetrahedral. What is the shape called tetrahedral? Okay, this is the shape called tetrahedral. 1 bond above, 3 bonds like this, a pyramid. Below you can see a pyramid, 3 bonds, above 1 more. This is called tetrahedral geometry. Let's see. Water can exist in tetrahedral geometry or not. Let me observe. Which is the central atom, dear all of you? Oxygen is the central atom. 2 bond pair, 2 lone pair, right? Okay. This 2 bond pair, let me draw like this. 1 lone pair here, 1 lone pair here. All of you please observe. Is it looking like a tetrahedral geometry? Yes or no? See, this is the shape of tetrahedral. 1 bond, 2nd bond, 3rd bond, 4th bond. But instead of bonds here, what we have? 2 lone pair. That's it. See the shape. See the arrangement. See the arrangement. It's like a tetrahedral, right? 1, 3 below. Why geometry tetrahedral? Because when you considering the geometry of a molecule, you have to consider both bond pair and lone pair, how they are located. Now come to the case of shape of the molecule. What is the shape of a molecule with a 2 bond pair and 2 lone pair, especially bond pair only, right? So the shape is equal to, here again, bent geometry, bent, or we can call it as V shape. Bent or V-shaped molecule. Clear all of you? So let's see that. So here, let me just draw the shape of water, okay? I told you it is bent geometry. So oxygen is there. Here one hydrogen, here one hydrogen. Okay, where is the 2 lone pair? 2 lone pairs are like this. 2 lone pairs are like this. Clear all of you? So why? You can see the hydrogen. See, when you calculating the shape of a molecule, I told you just to look into that how the bond pairs are located. They are located a bent geometry. Why they bent? Why they bent geometry? Because dear all of you, can you see this is a lone pair? This is a lone pair. Lone pair repulsion is very greater. When they repel very greater, the bond can come closer. Bond can come closer. And just note it all of you. What is the bond angle in water? That's around 104.5 degree. See, bond angle again reducing. Why? Because there are more repulsion. Bond angle is 104 point. This is a experimental data. All of you remember. Water bond angle is 104.5 degree. Alright. So we calculated the geometry, tetrahedral shape, the geometry. The shape is bend or V shape. Let's calculate the hybridization. Okay. Hybridization is calculated by what, dear all of you? Sigma bond and lone pair on the central atom. Let's calculate. How many sigma bonds are there on this oxygen? 1, 2, right? 2 sigma bond. How many lone pairs are there? 1, 2. Okay, total is equal to 4. If your hybridization sum is equal to 4, we have to mix first 4 orbital. Which are the first 4 orbital? 1 s orbital, 3 p orbital, right? So the hybridization is which one? sp3 hybridization. Can you tell me what is the molecule type? What is the molecule type? Which is the central atom? Oxygen. How many central atom you have? Only one, right? Therefore, A. How many surrounding element? 2 surrounding element hydrogen. Therefore, B2. How many lone pair? 2 lone pair. Therefore, E2. A represent last time, A represent central atom, B represent number of surrounding element, E represent number of lone pair. So the type is what? AB2E2. AB2E2. In the last slide, I will give you all the question like what are the shape, geometry we discussed. 2 bond pair, 2 0 lone pair, 2 bond pair, 1 lone pair, 2 bond pair, 2 lone pair. All together, I will give you a table that you have to learn further. For the reference, you can take it there. But here we are discussing how to find out detail about all things together. Next one. We can go to. So this is the shape of water, okay? This is oxygen atom. This is 2 hydrogen atom. 1 lone pair will be here. 1 lone pair will be here. What is the bond angle? It is 104.5 degree. Clear all? Okay. Let's go to the next system. We have 2 bond pair, 3 lone pair. 2 bond pair, 3 lone pair. So what are the system we completed? 2 bond pair with a 0 lone pair. 2 bond pair, 1 lone pair. 2 bond pair, 2 lone pair. This is the last system here. 2 bond pair, 3 lone pair. Alright. One of the example is XeF2. Xenon is the central atom. Atomic number actually 54. I'll give a clue. Xenon is a noble gas. What are the noble gases? The 18th group element: helium, neon, argon, krypton, xenon, radon. So xenon is a noble gas. Such a way you remember. Xenon is a noble gas. What is the speciality of the number of valence electron in xenon? You know, in noble gases, the valence electron, 8 electrons are completed. So what is the valence electron on xenon? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It is surrounded by which element? Fluorine. As I told you to notice 4 elements: fluorine, chlorine, bromine, iodine. They are halogens. All halogens valence electrons are 7. Suppose if you don't remember that, no problem. What is the atomic number of fluorine? 9. What is the configuration? 2, 7. Valence electron 7. So each fluorine require one more electron to complete its octet. Yes or no? So let them take from xenon. Okay, right. Please count, all of you, what is the number of bond pair and lone pair? There are 2 bond pair and 3 lone pair. System is correct. 2 bond pair, 3 lone pair. Okay, take the sum to calculate geometry. 2 plus 3 is equal to 5. Look into the table. If the geometry, if the sum of bond pair and lone pair is, if it is equal to 5, what is the geometry we discussed? That is called trigonal bipyramidal geometry. Trigonal bipyramidal. Let me draw that. Okay, there is a triangle, trigonal, one pyramid above, one pyramid below. Let me show you that. I'm taking the compound Xc. All right, Xc. I'm just drawing like this. This is one lone pair. Total 3 lone pairs, right? One lone pair, second lone pair, third lone pair. All right. And I'm just to mention the bond pair like here. This is one fluorine. This is one fluorine. Look into that. How many lone pairs are there? 3 lone pair and 2 bond pair. Alright. If you want to calculate the geometry of a molecule, we have to know we have to consider both bond pair and lone pair. Correct. So these are lone pair, these are bond pair. All of you please collect these lone pairs together. Are you getting a triangle? If you connect all these lone pairs together, you're getting a triangle, right? So trigonal is over. Then what is that pyramid? How you can make a pyramid, right? All of you just to collect each bond with a fluorine here. Alright. Can you see there is a pyramid? This is triangle, the plane. Above there is a pyramid. Similarly, below another pyramid. This is called trigonal bipyramidal geometry. Trigonal bipyramidal. Then what is the shape? When you calculating the shape of the molecule, we are not assigning or we are not looking to the lone pair how they located, right? Only bond pair. See, XeF2 means I can say this is the geometry. Sorry, the shape. This is the what? Or you consider the same thing. Okay, you consider the same thing. You consider the same structure which I noticed here. All of you please look into the only bond pair. This is the bond, right? This is the bond pairs. How they located? Are they linear? Are they linear? Yes, they are linear geometry, right? I can draw the another way, the same geometry like this. This is the linear one and 3 lone pairs like this. See, if when you look into the only bond pair, they are arranged in a linear pattern. So what is the shape? Linear again. Linear again. Now, what is the bond angle here, dear all of you? This is 120 degree, 180, right? A linear. What is the bond angle? It will be 180 degree in this system. So if if any system having 2 bond pair and 3 lone pair, we can say that geometry is equal to trigonal bipyramidal and the shape is equal to linear shape. What is the hybridization? Hybridization is equal to sum of sigma bond and lone pair. How many sigma bonds are there on xenon? 1, 2. 2 sigma bonds are there. How many lone pair? 1, 2, 3. 3 lone pairs are there. Total is equal to 5. Hybridization means what? Intermixing of atomic orbital. So 5 is the sum. Take your first 5 orbital. Okay, let me take 1 s orbital. Okay, ready? And 1 p orbital, second p orbital, third p orbital. So sp3 over, but only 4. We need one more. S over, 3p over. Let's go to d. Take 1 d orbital. So 1 s orbital, 3 p orbital, 1 d orbital. So what is hybridization? sp3d is the hybridization for the system. What is the molecule type you have? Which is the central atom? How many central atom you have? Only one central atom. Therefore, A. How many surrounding element? 2 fluorine. Therefore, B2. How many lone pair? 1, 2, 3. Therefore, E2. So, the type is what? AB2, E2 type. Alright? AB2, E2 type. Clear all of you? Okay, we can go to the next system. So this is the shape, okay? This is the shape. You can see the central one is xenon, the white colored one is the fluorine, and this yellow colored one representing the lone pairs. Alright, lone pair. You can see that. If you look in such a way, you can see a triangle and a bipyramid. If you look in like this, if you consider only the bond pair, it is linear geometry. Linear shape, sorry. So geometry is trigonal bipyramidal, shape is which one? Linear. Next system. 3 bond pair, 0 lone pair. One of the example, BF3. Most time they will ask you this type of question, BF3. Okay, let me take boron. Boron atomic number 5, right? So what is the configuration? 2, 3. So valence electron is 3, 1, 2, 3. It is surrounded by 3 fluorine atom. As I told you, each fluorine having already 7 electron in their valence shell, they need 1 more electron to complete their octet. Okay, let them take from fluorine. So can you see, dear all of you, how many bond pairs are there on boron? There are 3 bond pair. Can you see any lone pair on boron? No, right? Yeah, 0 lone pair. Alright, 3 bond pair, 0 lone pair. Take the sum, 3 plus 0 is equal to 3. If the sum of bond pair and lone pair, if it is equal to 3, what is the geometry we studied? Trigonal planar. Trigonal planar geometry. Let me draw the shape, geometry, okay? What is trigonal planar? B, F, F, F. See, trigonal. If you connect all together, you are getting a trigonal planar. Why they call planar? This is on the plane. If you consider this is the plane, boron, fluorine, fluorine, fluorine. Yeah, they are on the plane. This is called trigonal planar. Can you expect what is the bond angle here in BF3? What is the bond angle, dear all of you? You know, this is total, it is 360, right? Total, if you consider 1, 2, 3, total it is 360. So each one will be 120 degree. Okay, in trigonal planar geometry, what is the bond angle? 120 degree. Okay, can you guess it? What can be the shape? I told you one of the point in the previous one of the example. What was that? Can you remember? If the number of lone pair equal to 0, yes, if the number of lone pair equal to 0 in a system, geometry equal to shape. Geometry and shape both are same. Okay, so trigonal planar means here also shape also we can say trigonal planar. Trigonal planar. Why? Why when lone pair equal to 0, geometry and shape are equal? Dear student, there is no lone pair, right? So lone pair, bond pair, something repulsion, nothing is there. This is the exact existence of the molecule. So trigonal planar. So let me go to the hybridization. Okay, hybridization is calculated by the sum of sigma bond and lone pair. How many sigma bonds are there on this boron? 1, 2, 3. 3 sigma bond. Any lone pair? No, 0. So total sum is equal to 3. If your total sum is equal to 3, you have to mix first 3 orbital. Which all are first 3 orbital? S orbital, 2p orbital. That's it. So what is hybridization? sp2. sp2. What is the molecule type? How many central atom you have? Only one boron, right? Therefore A. How many surrounding element? 1, 2, 3. Therefore B2. Any lone pair? No. So, sorry, not B2, right? B3. Total there are 3 surrounding elements, right? Yes, correct. AB3. AB3 is the type. Now, hope you clear the pattern, right? Now, let's make it fast. See all of you the geometry? This is the geometry of BF3 molecule. Not only BF3, any system with 3 bond pair and 0 lone pair. Okay, always trigonal planar. See what is the bond angle we studied? This is one bond angle 120 degree. This is again 120 degree. This is again 120 degree. Correct? So this is the total 360. That's the one. Next we can go to the system. 3 bond pair, 1 lone pair on the central atom. Example ammonia. What is the geometry and shape of ammonia? Let's find out. Which is the central atom? Nitrogen. Nitrogen atomic number 7. So 2, 5 is the configuration. Valence electron 5. So 1, 2, 3, 4, 5. Alright. It is surrounded by 3 hydrogen atom. You know, each hydrogen need 1 more electron. Okay. So calculate. There are total 3 bond pair and 1 lone pair. Take all of you the sum of bond pair and lone pair. 3 plus 1 is equal to 4. If the sum is equal to 4, what is the geometry we studied? See the table. Geometry is equal to tetrahedral. Tetrahedral geometry. Tetrahedral. Let me just draw the shape. Okay. Nitrogen, 3 hydrogen atom and 1 lone pair. This is the tetrahedral geometry, right? What is tetrahedral shape? This is the tetrahedral shape. See the existence. If you consider lone pair and all bond pair, it is existing a tetrahedral geometry. Okay, fine. Now what is the shape? If you want to calculate the shape of the molecule, you just look at only the bond pair, how they are located. See all of you, 1, 2, 3. You no need to bother about lone pair, okay? No need to bother about lone pair. How these bond pairs are located like this? Yes or no? What is this? It is like a pyramid. It is like a pyramid. So what is the shape we can say? This is called trigonal pyramidal geometry. Okay, when you calculating geometry, you have to consider both lone pair and bond pair, how they located. It is like a tetrahedral geometry. But when you look into the shape of the molecule, you look into only the bond pair, how they are located. It's just like a pyramid. Just like a pyramid. I will show you. This is the shape. Like this is the nitrogen and the other 3 hydrogen like this. Where is the lone pair? It will be above. Alright, now NH3, just to keep in mind all of you, what is the bond angle in ammonia? Experimental data, they will ask you for your exam, okay? Bond angle is nearly 107 degree. Bond angle of ammonia is 10. All bond angle here it is 107 degree. So we calculated the geometry, shape. Let's go to hybridization. Now I hope you can able to answer without my help. So hybridization is equal to the sum of sigma bond and lone pair. How many sigma bond, dear all of you? 1, 2, 3. 3 sigma bond. Any lone pair on nitrogen? Yeah, 1 lone pair. So total is equal to 4. If your total sum of hybridization is equal to 4, first 4 orbital, all of you mix it. Take your 1 s orbital, p, 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 total 4 over 1 s and 3 p orbital. So what is hybridization? sp3. What is the molecule type? How many central atom you have? Only 1 central atom, nitrogen. Therefore A. How many surrounding element? Hydrogen, hydrogen, hydrogen. 3 are there. Therefore B3. How many lone pair? Only 1 lone pair. E. So what is the type? AB3 E type. Now it is easy, dear student. So keep in mind, when the lone pair here, why here geometry and lone pair both are different? Because there is a lone pair. If there is a lone pair, then definitely geometry and the structure will be, the shape will be different. If lone pair is 0, both are equal. Alright. Come to the next point. If the system contains 3 bond pair and 2 lone pair, what is the geometry shape? For example, ClF3. I am taking the central atom chlorine. You know, chlorine is a halogen. Its valence electron is what? 7. It is surrounded by which element? 3 fluorine atom. 1, 2, 3. Each fluorine need 1 electron. Okay, let them take. Okay, calculate, dear all of you, total how many bond pair and lone pair on central atom chlorine. 1, 2, 3. There are 3 bond pair and 2 lone pair. Alright? Okay, please take the sum to calculate geometry. 3 plus 2 is equal to 5. Okay, fine. If the geometry, the sum of bond pair and lone pair equal to 0 is, what is the table we studied? If it is equal to 5, trigonal bipyramidal. Geometry is called trigonal bipyramidal. Trigonal bipyramidal. Let me draw the shape. Okay, trigonal bipyramidal. Chlorine is the central atom. It is surrounded by 3 fluorine and 2 lone pair. Alright. So let me represent the geometry like fluorine, fluorine, fluorine and 2 lone pair. Alright. Are you feeling it's like a trigonal planar, trigonal bipyramidal geometry? No? Let me just draw another shape. Okay. Cl, F, 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 2 lone pair. Now are you feeling a trigonal planar? See all of you. This is the triangle. This is the triangle, 1 pyramid above, 1 pyramid below. Yes or no? The same thing here. Okay, so this is the geometry of the molecule. So every system with the total sum of bond pair, lone pair, if it is equal to 5, always trigonal bipyramidal. Alright, now what is the shape? When you're calculating the shape of the molecule, I told you, please forget about the lone pair, how they are located. How the bond pairs located here, all of you? 1, 2, 3, right? or like this one, 1, 2, 3. It's just like a alphabet. What is that? It is just like a T shape. All of you see T shape, like here, T shape, T shape. So the shape of the molecule we will call it as T shape, T shape. Let's go to the hybridization. Hybridization is equal to the sum of sigma bond and lone pair. How many sigma bond on chlorine? 1, 2, 3. 3 sigma bond. How many lone pair? 1, 2. 2 bond pair. 2 lone pair. Total sum is equal to 5. So let us mix 5 first orbital. Okay. S orbital, P, P, P. So 1 S over, 3 P orbital over, but only 4 we mixed, right? We need 5. After P orbital, what we have? D orbital. So sp3, D is the hybridization. Alright? sp3, D hybridization. What is the molecule type? How many central atom you have? Only one central atom, chlorine, A. How many surrounding element? 3 fluorine, therefore B3. How many lone pair? 2 lone pair, therefore E2. So the type of the molecule is AB3E2. Now got the method, all of you? Correct? So okay, let's go to the next topic. Next concept. So this is the geometry, okay? You can see that there is a T-shaped molecule. Where is the lone pair? 1 lone pair here, 1 lone pair here. See, there's a T-shape. Right. What is the bond angle here? What is the expecting bond angle here? What is this bond angle? It's 90 degree, right? What is this bond angle? 90 degree. If you consider this bond angle, 180 degree. Like that, we can able to answer it. Next system, 4 bond pair, 0 lone pair. The most important one of the structure. 4 bond pair, 0 lone pair. Let's show with the molecule methane, one of the example. Carbon is the central atom. You know, carbon is tetravalent. So total there are 4 valence electron. It is surrounded by how many hydrogen atom? 4 hydrogen atom. Alright. Each hydrogen need 1 electron. Let them take. So total how many bond pair, dear all of you? 1, 2, 3, 4. There are 4 bond pair. And is there any lone pair? No lone pair. Take the sum. 4 plus 0 is equal to 4. If the sum of bond pair, lone pair equal to 4, what is the geometry we studied? Tetrahedral geometry. Alright, tetrahedral geometry. So first of all, you study each bond pair, lone pair sum we studied in one of the table. 2, 3, 4, 5, 6, 7. Corresponding geometry we have to know. Okay. Now what is the shape? Okay, let me just draw the geometry of CH4 in tetrahedral shape. What is tetrahedral shape? Carbon, hydrogen, 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 hydrogen. This is the tetrahedral shape. 3 hydrogen below, 1 hydrogen above. Okay. Dear all, what is the shape here? Anyone remember? You can able to answer. Because I told you, when the system contains 0 lone pair, if the system contains 0 lone pair, we studied that its geometry and the shape both are equal. So here it is tetrahedral, here also tetrahedral. Why they are both are same? If there is no lone pair, no repulsion. No repulsion between lone pair, bond pair. The bond pair will be stay as it is. Because bond pair not repel too much. Keep in mind all of you, what is the normal bond angle? All bond angles are similar in tetrahedral, all are equal. Keep in mind, normal tetrahedral bond angle is 109 degree 28 minute. You know, bond angle can say in the minute and second. So normal tetrahedral bond angle is 109 degree 28 minute, or you can convert minute into the degree, 109.5 degree. Both are same. Normal tetrahedral bond angle is 109 degree 28 minute or 109.5 degree. Alright. So this is the tetrahedral everything. Let's go to the hybridization. Hybridization is equal to again sigma bond and lone pair. How many sigma bonds are there? 1, 2, 3, 4. 4 plus. Any lone pair? No. So total 4. If it is equal to 4, what is hybridization now all of you? Mix the first 4 orbital. 1 s orbital, 3 p orbitals. So what is hybridization? sp3. Are you clear? Are you clear? sp3. What is the type? What is the type? How many central atom carbon? Only 1. How many surrounding element? 4 are there. Therefore, B4. Any lone pair? Nothing. So the type is what? AB4. AB4. So like that, you can able to answer, or you can able to, if you know the table, because the table in the sense this bond pair, lone pair you can calculate easily, right? Hybridization also you can calculate easily, right? Only the geometry shape when you calculating, we know the data first of all. This if you take the bond pair lone pair sum, if it is equal to 2, okay, linear. If it is equal to 3, trigonal planar. If it is equal to 4, tetrahedral. The table which I show you before, just all of you learn first, then come to the point. And shape, I told you, just to look at that, how the bond pairs are located, how their arrangement, that's only. Finally, all these examples together, I will show you last 2 slides in the end of this video. Then you can able to understand easily all the concept. You can take it for their further reference. Let me show you the shape of the molecule. This is the shape, tetrahedral shape. Can you see? The central one is carbon, and the surrounding and 1 hydrogen above, 3 hydrogen below, like a pyramid. So overall it is called tetrahedral geometry. What is the bond angle? 109 degree, 28 minute. Okay. Next system. 4 bond pair, 1 lone pair. Example is SF4. Which is the central atom? Sulfur. Sulfur valence electron is, we discussed before, 6. It is surrounded by 4 fluorine atom, right? 4 fluorine. Each fluorine need 1 electron. Okay. How many bond pair? 1, 2, 3, 4. There are 4 bond pair and 1 lone pair. 4 bond pair and 1 lone pair. Okay. Take the sum, 4 plus 1 is equal to 5. If sum of bond pair and lone pair equal to 5, what is the geometry? Trigonal bipyramidal. Trigonal bipyramidal geometry. What is the shape? What is the shape, dear all of you? I am just drawing the shape first of all. What is trigonal bipyramidal? Sulfur is there. Triangle, let us make it first, okay? 2 fluorine and 1 lone pair. This is triangle is ready, and 1 fluorine above, other fluorine here. Okay, so just look into all of you. Where is the triangle? This is the triangle, right? So triangle is there, 1 pyramid above, 1 pyramid below. Trigonal bipyramidal geometry. What is the shape of the molecule? If you want to know the shape of the molecule, please hide your lone pair. What is the shape? I'm just drawing, in order to understand the structure clearly, I'm just drawing the structure in another way, okay? I'm taking the sulfur, alright, sulfur is there, and here 1, 2, 3, 4, these 4 bond. Can you see the linear bond? I'm just drawing like this, okay, fine. And these 2 fluorine I'm writing like this, okay, and this is the lone pair. Clear all of you? Both are same or not? Say, yeah, here also you can take, this is the triangle, right? This is the triangle, 1 pyramid here, 1 pyramid here. I'm just rotating this molecule, I'm just rotating like this, that's it. Now, just hide this lone pair. What is the shape? Did you see seesaw shape? You know seesaw? What is seesaw geometry? You know, this is the seesaw geometry, right? Seesaw geometry. You know, 2 students or 2 children will be there, and they will play seesaw, right? This is the geometry, seesaw geometry. With which system? If the system contain 4 bond pair, 1 lone pair, what is the shape of the molecule? That is equal to seesaw shape, seesaw geometry. Let's go to the hybridization. Hybridization is equal to the sum of sigma bond and lone pair. How many sigma bond? 1, 2, 3, 4. How many lone pair? 0. No, 1 is there, right? Sorry for that. How many lone pair? 1. So total is equal to what? 5. 4 sigma bond, 1 lone pair. Total 5. First 5 orbital, please mix it. 1 s orbital, 3 p orbital, 1 d orbital. So hybridization is what? sp3 d orbital. What is the molecule type? Your central atom only 1, A. 4 surrounding elements are there, B4. 1 lone pair, therefore E. So the type is what? AB4E. Clear all of you? Now able to do yourself, especially hybridization, molecule type, etc. Alright. Next one. So okay, this is the geometry. This is the sulfur. This is the lone pair. 2 fluorine here, 2 fluorine here. Which is the triangle actually? Triangle, while you're making, connect this one. Okay, this is the triangle. 1 pyramid here, 1 pyramid here. Alright. Next one. With a system 4 bond pair, 2 lone pair, what is the geometry, shape, everything? For example, XeF4. Xe. As I told you, xenon is a noble gas. So valence electron 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Surrounded by how many fluorine? 4 fluorines are there. Alright, 4 fluorine. Each fluorine need 1 electron. So you can see there, total there are 4 bond pair and 2 lone pair. 4 bond pair, 2 lone pair system is total sum. 4 bond pair, 2 lone pair, total is equal to 6, right? If the sum of bond pair, lone pair is 6, what is the geometry we studied from the table? That is called octahedral geometry. Octahedral is also known as square bipyramidal geometry. I'll show you the figure, okay? We have xenon, alright, xenon. Octahedral means square bipyramidal. Square bipyramidal. Okay, 4 fluorine, right? Let me place like this. 1, 2, 3, 4. Okay, I made a square. Alright, dear students, square is ready. Where is the 2 lone pair? 1 lone pair above, 1 lone pair below. So when you're calculating the geometry of a molecule, I told you, you have to consider both bond pair and lone pair, how they located. This is square, alright? This 4 is called square. If you consider lone pair, 1 pyramid above, the below, 1 lone pair, like this. This is the xenon central atom, fluorine, 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 fluorine. It's making a square, right? It's making a square here. 1 lone pair above the plane, 1 lone pair below the plane. What is the geometry? It's called square bipyramidal. It is also known as octahedral geometry. Now, what is the shape, dear all of you? When you calculating the shape of the molecule, as I'm reminding you once again, you just forget about the lone pair. If the lone pair is not there in the system, what is that? It is simply square planar, right? So what is the shape? We can say square planar shape. Let's go to the hybridization. Hybridization is calculated by the sum of sigma bond and lone pair. How many sigma bonds are there on xenon? 1, 2, 3, 4. 4 sigma bond. How many lone pair? 2 lone pair. Total is equal to what? 6. Alright. So what all orbital we want to mix it? You have s orbital. You have 3 p orbital. You have 5 d orbital. No need all 5, right? Only we need 6. So s orbital, okay, p orbital. So total 4 over, we can take 2 more d orbital. So total 6 orbital we mixed. What is hybridization? sp3d2. sp3d2. And what is the molecule type? Xenon, only one xenon central atom A. Surrounding element is total 4, therefore B4. 2 lone pair, therefore E2. So the type is AB4E2. Clear all of you? Next question. If the system contains 5 bond pair, 0 lone pair. Again here one more data. Here lone pair equal to 0. Lone pair 0 mean geometry and shape are equal. Let's see. One of the example PCl5. The most important example, phosphorus. Phosphorus atomic number 15. So electronic configuration 2, 8, 5. 5 valence electron. So 1, 2, 3, 4, 5. Surrounded by how many chlorine? 5 chlorines are there. Alright, 5 chlorine. Each chlorine need 1 electron. Okay, let them take. How many bond pair? There are 5 bond pair. Any lone pair? No, right? No lone pair. 0. Take the sum of bond pair and lone pair. 5 plus 0, 5. If the total sum of bond pair, lone pair equal to 5, what is the geometry we studied again? Trigonal bipyramidal geometry. Let me draw phosphorus. Let me make a triangle first. Chlorine, chlorine, chlorine. Okay, triangle is ready. Triangle is ready. 1 chlorine above the plane, 1 chlorine below the plane. So this is a pyramid, a below a pyramid. Trigonal bipyramidal geometry. Let's see this one. This is the geometry. Alright, phosphorus is at the center. These 3 chlorines making a triangle. 1, 2 fluorine, chlorine above. That's it. How the pyramid is clear, no? If you connect all these 3, you can see trigonal pyramid. Above one pyramid, similarly below another pyramid. Trigonal bipyramidal. Now, we can go to the shape. As I told you, lone pair equal to 0 here. So geometry equal to shape. So trigonal Same thing, trigonal bipyramidal geometry. What is the hybridization? Hybridization is simple. Hybridization equal to sigma bond and lone pair. How many sigma bond on this compound? 1, 2, 3, 4, 5. 5 sigma bond. Is there any lone pair? No lone pair. So total is equal to 5. So mix first 5 orbital, 1 s orbital, p, p, p. 4 over no? Let me take one more d. So the hybridization is sp3d. What is the type? Only one central atom here. Therefore A. 5 surrounding element. B5. No lone pair. Nothing. So the type is what? AB5 geometry. What is the bond angle here? What are you expecting the bond angle? Let me tell you. This is very important to discover the bond angle, dear all of you. This is a triangle, right? This is the triangle. So what is this bond angle? Overall, it is 360 degree. So this is 120. This is 120. This also 120. All right. And what about this bond angle? Which one? When you consider this bond angle, so which one I said 120 degree? This is 120. All right. This is 120, 120, 120. All right. What about this bond angle, the perpendicular one? If you consider this, that's 90, right? 90, the perpendicular one, and you consider one perpendicular and the plane bond. If you consider, the bond angle will be 90 degree. This is 90, here it is 90, here it is 90. All right, that's a system. So 120 degree is there, 90 degree is there as a bond angle. Next system, 5 bond pair, 1 lone pair. Example BRF5. Central atom bromine. As I told you, fluorine, chlorine, bromine, iodine, all are halogens. Their valence electrons are 7. Alright, bromine 1, 2, 3, 4, 5, 6, 7. It is surrounded by 5 fluorine atom. Okay, each fluorine need 1 electron. Let them take. Total how many bond pair? 1, 2, 3, 4, 5. There are 5 bond pair and 1 lone pair. Take the sum. 5 plus 1, 6. If it equal to 6, what is the geometry we studied? Again, octahedral or square bipyramidal. Let me draw BR. 5 fluorine, right? 1, 2, 3, 4. Square is ready. Square is ready. 1 fluorine above. So total 5 fluorine over. 1 lone pair is there. Let me draw like this. Dear all of you, what is this geometry? What is this geometry? When you consider the geometry, please consider the bond pair and lone pair all together. This is square, right? This is square, 1 pyramid above, 1 pyramid below. Because lone pair also we have to consider as a bond. So this is square, pyramid, pyramid. Square bipyramidal, that is also known as what? Octahedral. What is the shape? When you calculating the shape, just hide your lone pair. Okay? Lone pair is not there. Then what you have? Square, just 1 pyramid. Correct? This is the pyramid. Just a square pyramid like this. See, this is the bromine central atom, fluorine, 5 fluorines are there. This is the one making square. If you connect here, it will get a pyramid, right? It will give you a pyramid. Where is the lone pair? When you consider lone pair also, that becomes geometry. Lone pair means it will be below. Then there will be a pyramid below also. That is called square bipyramidal or octahedral geometry. But the shape is which one? Square pyramidal. Just 1 pyramid. Square pyramidal. Let's go to the hybridization. Hybridization is equal to sum of sigma bond and lone pair. How many sigma bond? 1, 2, 3, 4, 5. 5 sigma bond. How many lone pair? Only 1. Total is 6. 6 mean what all orbital we want to mix it? 1 s orbital, 3 p orbital, remaining 2 d orbital. Total 6 over no? 1 s orbital, 3 p orbital, 2 d orbital. Right? 6. What is the molecule type? Only 1 central atom. Therefore, A. How many surrounding elements are there? 5 surrounding elements. Therefore, B5. And only 1 lone pair, E. So the type is what? A, B5, E type. Clear all? Okay. A few more compounds on the left. Next system. 6 bond pair, 0 lone pair. Example SF6. As I told you, sulfur valence electron is 6 because the atomic number is 16. It is surrounded by 6 fluorine atom. Okay, each fluorine need 1 electron. Let's count it. How many bond pair? There are 6 bond pair and 0 lone pair in the system. Yes or no? Take the sum. 6 plus 0, 6. If the sum of bond pair and lone pair equal to 6, what is the geometry we studied? Octahedral geometry or square bipyramidal. Let me draw. Sulfur, 1 fluorine, 2nd fluorine, 3rd fluorine, 4th fluorine. It's making a square. 1 fluorine above, 1 pyramid is ready. The other fluorine below 1 pyramid. This is called square bipyramidal or octahedral geometry. Clear all of you? Now, what is the shape? What is the shape? Here again, yes, you got the idea. Lone pair equal to 0, right? Lone pair, there is no lone pair, or lone pair 0 mean shape is equal to geometry. So let me write here also octahedral shape. Let's go to the hybridization. What is hybridization? Hybridization is equal to how many sigma bond? 1, 2, 3, 4, 5, 6. Any lone pair? No. 6 orbital, all of you mix it. S orbital, 1 S orbital ready. 3 p orbital, so total 4 over. We need 6, right? So remaining 2 d orbital. And what is the type? Only one central atom, A. 6 surrounding element, B6. Any lone pair? No. So AB6 type. Now able to speed up? Able to speed up? Just a minute. I will show you the entire things in one slide. 1 minute. Second last system. Okay, this is the system. Okay, square bipyramidal. Can you guess what is the bond angle here? What is the bond angle, dear student? If you consider square, first of all, you know this will be 90 degree, right? 90 degree. Why 90? Total it is 360. No, 90. This is 90. Here it is 90. Here it is 90. Total 360 degree. What about the perpendicular bond and this bond? It always will be 90 degree. All right, like that. Next system. 6 bond pair, second last one. 6 bond pair, 1 lone pair. XeF6. Central atom xenon. Xenon is a noble gas, so 8 valence electron. It is surrounded by 6 fluorine atom. Each fluorine need 1 electron. Okay, so how many bond pair? 6 bond pair, 1 lone pair. Take the sum, total 7. Total 7. Sum of bond pair, lone pair 7 means we discuss the structure. Pentagonal bipyramidal geometry. Let me draw pentagon first of all. Xe 1, 2, 3, 4, 5. Can you see? This is a pentagon, right? Pentagon. Pentagonal bipyramidal. Where is bipyramidal? 1 pyramid above, 1 pyramid below. What is that? Only 5 fluorine over. No, 1 more fluorine is there. Okay. So 1 pyramid is ready, no? 1 pyramid. Where is the other pyramid? That is with a lone pair. Because geometry means bond pair, lone pair, all together we have to consider. So this is pentagonal bipyramidal. Now can you guess it? What is the shape? Shape means just to avoid the lone pair. This is pentagonal, just a pyramid. Correct or not? So this is called pentagonal, just a pyramid. So pyramidal. So this is the geometry. Okay. This is the xenon. Pentagon is the 5 fluorines are there as a pentagon, one pyramid below. This is called pentagon. What is the lone pair? Here. You can write it above. Okay, the bond you can write above, lone pair below, whatever, no issue. What is the bond angle in pentagon? What is each bond angle here, all of you? Total it is 360, no? So each bond angle is 72 degree. Because 72 into 5 equal to total 5 bonds, right? 1, 2, 3, 4, 5. Right, I'm just discussing about only the pentagon part. Okay, like this. Xe, F, 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 F. Right, each bonds when you consider 1, 2, 3, 4, 5. All are 72 degree. Total 72 into 5, 360 degree. And what about the perpendicular bond? It will be 90, no? Yeah, perpendicular bond when you consider this perpendicular bond with any of the bond when you consider, it will be 90 degree. This is the bond angle type. What is hybridization? Hybridization is equal to the sum of sigma bond. How many sigma? 1, 2, 3, 4, 5, 6. How many lone pair? 1 lone pair. It's equal to 7. 7 means you have to mix 1 s orbital, 3 p orbital, total 4 over, 1 s, 3 p over. How many d orbitals require? 1, 2, 3. 3 more d orbital, right? So the hybridization is sp3d3. What is the molecule type? Only one central atom, therefore A. 5, sorry, how many surrounding elements? 6, right? Therefore B6. Only one lone pair, E. So the type is AB6E type will come. Alright, AB6E type will come. The last structure we can enter, this is the maximum type of compounds they will ask you for your exam, okay? This is the last type, 7 bond pair, 0 lone pair. The example IF7. You know, iodine is a halogen, it having 7 valence electron. Alright, it is surrounded by 7 fluorine atom. Each fluorine need 1 electron, right? 1 electron. So let them take from there. Total how many bond pair, dear all of you? 7 bond pair, 0 lone pair. Take the sum of bond pair and lone pair, 7. If it is equal to 7, we will call it as pentagonal bipyramidal. Pentagonal bipyramidal. Let me draw iodine. First of all, you make pentagon 1, 2, 3, 4, 5. Yes, pentagon is ready. What about pyramid? 1 fluorine above, 1 pyramid, 1 fluorine below, another pyramid. Right? Pentagonal bipyramidal. Can I call here geometry equal to shape? Yes, because the lone pair is equal to 0. No lone pair. So therefore here also pentagonal bipyramidal geometry. So this is the geometry. Okay. This is the pentagon. This is the pentagon. 2 pyramid. Can you guess the bond angle? What is the pentagon bond angle? We discussed 72 degree, right? Each all are 72 degree. The perpendicular one will be 90 degree. Alright. What is the hybridization? Hybridization again, it is equal to sum of sigma bond and lone pair. How many sigma bond? Total 7. Any lone pair? No. Total is equal to 7. So 7 means 1 s orbital, 3 p orbital, remaining 3 d orbital, sp3d3. What is the molecule type? 1 central atom, therefore A. 7 surrounding element, AB7 type. Clear all? In the previous one we discussed AB7. Previous one it was AB6E, right? Because AB6E, here 1 central atom and 7 fluorine. Alright, so here these are the total maximum system we have to consider. Now let me give you overall conclusion for the system. See that. This is the overall topics we studied today. So here you can take a screenshot now. I'm just moving. Just to take a screenshot, this table actually we want to study. And how to find out the geometry, everything, that's what we discussed. So 2 bond pair, 0 lone pair, geometry is linear. You know, those cases where lone pairs are 0, as I told you, shape is equal to geometry. See, here lone pair 0, geometry, shape are similar. Here lone pair 0, geometry, shape are similar. Here lone pair 0, geometry, shape are similar. Clear or not? So hope you know how to calculate the hybridizations now. Molecule type. So very careful. The geometry and the shape. Not only this, right? We studied one more topic. So this is the next one. Okay. So this is the maximum. Just take a screenshot or pause the video. You can able to understand all the geometry, shape, the data. This data actually we have to study and follow the method once again. Okay, dear all. Hope you completed. So today we discussed a very vast topic in your chemical bonding chapter. How to determine the shape and geometry of a molecule. How to determine hybridization of a molecule. How to determine what is a molecule type. And how to determine the bond angle also. So dear all of you, if you practice all these example and this, if you know these 2 table which I show you. The first table, the second table. Alright, if you know this table data also, you can able to answer, or you can able to, I'm confident and confidently I can say that you're able to answer any kind of molecule, their all details like this. So hope you clear the doubts and the concept. Clear about the major topic is called VSEPR theory, valence shell electron pair repulsion theory. So dear all of you, keep practicing with the same example. We will meet again with some more concept from the same chapter, chemical bonding, in the upcoming classes. Thank you all. Bye.